Hello, today we're going to talk about 8-3, and 8-3 is about the number E. Before we get into E, I want to look at something that you guys are familiar with, and that is this symbol, which you probably all know is referred to as pi. And you know that when you were younger, your teachers just told you use 3.14 to approximate what pi actually means. Pi is a number that's going to continue on and on and on. We just use 3.14 to approximate the value. And since this number is going to go on forever and ever and ever, we use this symbol pi to represent its value. Just like that, we have the number E, and E is represented by a letter. So E is a number, just like pi is a number 3.14, E is representing a given number. And that given number comes from the formula 1 plus 1 over n, all raised to the n power. So if my n is 10 to the first power, and you can check this by plugging into your calculator, you get 2.594. If you plug in 10 squared in for n, you get 2.705. If you plug in 10 to the third, you get 2.717. 10 to the fourth is 2.718. 10 to the fifth, you get 2.718. So as n gets larger and approaches, this is our affinity sign, so as we plug in numbers for n and it gets larger and larger, we went 10, 100, 1,000, 10,000, 100,000. As those numbers of n get larger, our function is going to approach the value 2.718. So just like we use 3.14 to approximate the value of pi, we're going to use 2.718. That's representing E. We're always going to use that letter E, but you have to know that E is not representing some unknown value, that E is representing a number just like pi represents 3.14. E is what we talk about as the natural base, or the Euler number, and just like pi, it's an irrational number. That just means we can't write it as a fraction. Like 0.5 is a half. 0.6 repeating is 2/3. We can't take 2.718 and write it as a fraction. When you simplify x squared times x to the third, and we just finished up this chapter, you know that you're going to add those exponents, so we get x to the fifth power. If I have 3 squared times 3 to the fourth, my bases are numbers. I still don't change those bases, and I add the exponents to get 3 to the sixth power. The same is going to be true when you have bases of e's. When you're multiplying bases, you add those exponents, so I get e to the seventh power. If I have 10 divided by 2, I know that 10 over 2 reduces down to 5 over 1. If I have e, so if I'm dividing like bases, it doesn't matter if that base is a variable, a number, we subtract the exponent. 6 minus 5 gives us e to the first power. And when we have power to a power, we distribute in, so this becomes 2 to the third. And I have my base e, just like a number base or a variable base. A power to a power means I'm going to multiply that to get a negative 15x. We can't have negative exponents, so I've got 2 to the third on top, which is 8. And I move the e to the bottom, where that negative 15 becomes a positive 15x. And number 6, I've got the fourth root. So this is really 8 times 2, 4 times 2, 2 times 2. So I've got exactly 4 2s, so the 2 goes to the outside. And remember, if we have variable exponents or variable bases raised to exponents, or number bases raised to exponents, I need groups of 4. Well, this is e to the 8x, and I need groups of 4 of them, which means I can get 2 groups. If I need 4 and I have 8 of those x's, I have 2 groups. So that becomes e to the 2x. Alright, next I want you to evaluate this in your calculator, so get your calculators out. Alright, we're going to look at your calculator, and if you look at your calculator, e is in 2 spots. If you see your division sign on the right, and you do second your division sign, you get your e. That's not the one you want. If you hit enter, you see that you get that 2.718, and then it's going to continue on. If you look above on the left, so hit second and go all the way down, you see e raised to the x power. That's the one that we're going to want. So we get second natural log. Anytime you raise something to some power and there's multiple pieces, we always want to put that in parentheses. So that's the one we like just because it prompts you with parentheses. So if I want to put e to the third power, I hit that second, the ln, which is natural log, to the third power. You can close it out, you don't have to, it doesn't matter since there's just that one piece. We hit enter and we get 20.086. We go to our second one, second ln for natural log, and we have a negative 0.75, hit enter, and we get 0.472. And just know where your natural log button or where your E button is. I would not use this one. If you did use this one, second division, then you'd have to put the caret and the parentheses yourself. So that one does all the work for you. Alright, so back to our note sheet. When you are graphing the natural base of E, if you have the function f of x is equal to a, where the base is e raised to the rx power, if the a value, so if the number you're multiplying by e is greater than 0 and the rate that you're raising e to is greater than 0, then it's going to be an exponential growth. If your a is greater than 0 but your r is less than 0, then it's going to be exponential decay. So we've talked about exponential growth and decay the last couple days. Now we're going to apply that to your natural base. And we're not going to have big points here. We see that we're multiplying by a number greater than 0, and our rate is going to be greater than 0, which means it's exponential growth, which means we should expect our graph to look like this. And it's going to approach 0. Over here, we're multiplying by an a value greater than 0, but our rate is a negative 0.75. So I'm going to expect to see an exponential decay function. So just relating that to the exponential growth and decay that we've talked about the last couple days. Turn your sheets over. On the back is a review. We've talked about exponential growth problems and how they're related to the bank. And if you remember your interest, it's a is equal to p times 1 plus your rate over how many times it's compounded, that whole quantity raised to the how many times compounded, multiplied by how many years. So you're going to invest $100 at 10% interest. So this is our principal, that's how much we're investing at a 10% interest. So our rate is 0.10. How much will you have after 1 year if you compound it? So we're going to do yearly, quarterly, monthly, weekly, and daily. And I want you to press pause right now, and this is a review, so I want you to do A, B, C, D, and E on your own. Alright, if we are compounding yearly, our N is only 1, and we have earned $110. If we earn interest quarterly, where our N is 4 times a year, we earn $110.38. If we have monthly, then our N is 12 times a year, and at the end of that year we have $110.47. Weekly, we've got 52 for our N, $110.51, and if it's daily, 365, $110.52. Alright, what do you notice about how much you have given how often it is compounded? So here 110, we've got another 38 cents. We're adding 9 more cents, adding 4 more cents, adding 1 more cent. So as N, the number of times compounded a year, gets bigger, the interest grows slower. So the more times compounded, the less it kind of matters. The bigger or the less of a change it makes. So as N approaches infinity, we say that the interest is compounded continuously. And when you compound the interest continuously, then we have a new interest formula. And that new interest formula is A equals P times E raised to the RT power, where, as usual, A is the total amount in savings, P is your principal or your initial amount, R is your rate as a decimal and the percentage, so the percent is a decimal, and T is your time. So how much do you have if you invest $1,000 for 5 years at 7% interest compounded continuously? So we've got 1,000, that's my P, 5 years, my T, 7% is 0.07 as a decimal, and if it's compounded continuously. So only if it's compounding continuously do we use this new formula. We plug all that we know in, so A is equal to 1,000 times E raised to the 0.07 times 5. And this is where it's important to have that button on your calculator where it raises to both numbers. So let's look at our calculator. I have 1,000. Oh, let's clear that out. And then I'm going to do second ln, and I'm going to raise that to 0.07 times 5. Now I want that all of that being raised to the e power, so I make sure that I include both of those in the parentheses. And if my interest is being compounded continuously, after 5 years, I have $1,419.07. And that's going to be it for 8.3.